Hi pre-calc, I'm going over homework for 4.6. This is number 15. This is the standard table for number 15. I went over in the lecture how I created that. It was partly the unit circle and partly the reference angles of pi over 4. Okay, but this is the standard table, so this is what you're going to modify to do any tangent function if you're going to use this technique. So there's nothing inside the tangent function, which means that the x column will not change. There's no change. There's nothing multiplied, nothing divided, nothing added. Nothing's going on here. So that guy stays the same. But the y column is going to change by a third. So I'm going to multiply the y column by a third. VAs do not alter, so they just stay VAs. So I'm now going to make the new table. So again, the x column, the domain is not changing for these points. VAs stay VAs, but these values in here are going to come 1/3 of what they are. Okay, so that's my table. Now the period formula for the tangent is pi over b. B in this case is still 1. There's nothing here, so b is a 1. So if you just want to see this in detail, so this is pi over 1 or pi. So that's the period. The increment, the formula for tangent, or for all the functions is oops, I already did it. I always have to like slow down my brain. The formula is period over 4, but the period here is pi, so it's pi over 4. So that's your increment. The start and stop you always have to do. That's your interval. So the start for this, it usually would start at negative pi over 2. So you take the insides, which is x. So this one, because there's no change to the x, it will still start at negative pi over 2 and it will still stop at pi over 2. So you know what, I actually didn't have to do any of this because all of that will make this chart. Because if I start at negative pi over 2 and I add the increment, which is pi over 4, I get that, add pi over 4, I get that, add pi over 4, I get that. So I didn't actually have to do any of this, but if you wanted to see it, I've now done it for you. So this will actually match this because we did no alterations to the x column, so we didn't have to do any calculations for the x column. Okay, gang, then let me just put this up. I always just take a moment to figure out dimensions here. So this is 1.5, 3 over 2. This is 1/3. So these are a lot wider than this, a lot. Okay. So I guess I will just say that this is pi over 2 and this is negative pi over 2 and then this is negative pi over 4 and this is pi over 4, this is 0. Okay, so if this is 3/4, because if pi is 3, if this is 3/4, then 1/3 would be about 3/4. So this would be 1/4. So 1/3 would be a little bigger than that. 1/4, 2/4, 3/4. Okay. 1/3. Okay, I'm gonna go with about there. Just take your best. Just do the best you can. All right. So then, if I put down the other values, so then negative pi over 4 and negative 1/3. Oh, now I'm putting down the points. Before I was just trying to get the increments correct. All right, so I'm putting down these values. So I'm doing like negative pi over 4 and 1/3. I'm doing 0 and 0 and pi over 4 and 1/3. Okay, and then I'm going to draw the graph. Right, and then just try to do like a photocopy of that the best you can, on the left side or on the right side, doesn't matter. Some of you give me like these perfect, beautiful graphs. Okay, let me, oh, I gotta get over there. Sometimes a little hard to multitask here, but I think I got this guy. All right. It goes there. This goes here. Okay, gang. And then there we go. That's y equals to 1/3 tangent x. And just to confirm that you've got the gist of it, when you put the 1/3 in front, what it's doing is it's a horizontal compression. So instead of these like being pulled up quicker, they're like flatter. They look flatter into the axis. That's what that 1/3 does. It's sort of smushing it. It's smushing it right around the origin of each of these segments. Okay, catch you in another video. Hope that helped. Bye-bye.